Welcome back to elementary statistics. We are going to be looking at the variance and the standard deviation. We're going to be showing an example of these step by step, and then we're going to look at the faster way to do it with t equal. Okay, so the variance is looking at the total number of, or the total value, I should say, of varying values differing from the mean squared, right? If you look at the equation on the left, that's what we're essentially getting. We're getting the sum of each of the values minus the mean squared, and then we're dividing that by the number of observations minus 1. We're about to look at an example of this. So we're trying to get the overall difference of all of those values from the average. So if we have, let's say in our example from a few videos back, an average of what I think it is 26,000, but we had, what was it, 60% of the values were 0. When we subtract 0 from the average, we're going to be getting negative 26,000, right, for those values. Then we're going to square that negative 26. We're always going to end up with a positive number. We're going to take the sum of all of those values, and then we're going to divide it by n minus 1. There were 20 values, so that would be 19 values. When we take the standard deviation, we are just taking the square root of the variance. So we're looking for the average adjusted value of each of those values that we have from the mean. We're looking at that, the difference. Okay, so let's look at an example because it makes sense when you see the data. We have that data set. Let's go ahead and let's just look at the table first of all. So select star from table measure, and we will see all of our values. And these were our 20 values. Again, you can look at the previous video where we were looking at the average and the median. And so we have some pretty large values at the end, but we have most of our values are 0. Okay, so the first step, if we were going to calculate the the standard deviation, is we want to get the variance. So the first thing to do to get the variance is we can look at the balance. And the great thing about doing CTs is I can do inner queries so that we can look at what we have before we move on. And what we'll see is the balance, of course, that we selected. We have the average balance, which we knew was that 26,750 figure. So what is the difference of this value, this balance, minus the average, right? So 0 minus 26,750 is negative 26,750, right? So that's that difference. And then we're going to square it, right? So, of course, we have 60% of these values that are the same, so we would expect to get the same answer here. But as we have this difference, you can see that, for instance, 5,000 minus 26,000 is less, or actually is more because it's a lower negative number. Or a higher negative number, depending on how you look at that. And then we have the 300,000, and we have these squared values. So what we're doing here, we're still not calculating the variance, but we have this part of the equation, the sum part, done. Now what we want to do in this next step is we're going to, we are going to get the sum of this total here at the very first step of this next part of the query. So we get the sum of these squared values, and then we're going to divide that by 19. That's n minus 1, the number of observations, which in this case is 20. We're going to divide that by 19, n minus 1, and that is our variance, which is, I believe, 4 billion. If I were to take this, put in some commas, just to make it clear, so 4.7 billion, and then our standard deviation appears to be 68,900. Okay, now again, we're taking just the square root on the standard deviation of the variance, so it's pretty straightforward. Looks complicated, but the great thing about t-SQL is we can just use and I know this is going to feel like cheating after we just did that, but we can just use the variance and the standard deviation. There are built-in equations, right? So we can just run this query, and we get pretty much the same result as we would expect. In fact, we get the exact same result. Or very close, at least on this. Now we get the exact same result. My eyes aren't that good, clearly, but as we can see, it's much faster. So you can use VAR and then the column, and then you can use standard stdev and then the column for that. And then, of course, if we want to check our work, because in math we can prove our work, what we can do is we can square, we can take the square root of the variance and see if we get the standard deviation, and we can take the square of the standard deviation and see if we get the variance from these reported figures if you want to prove your work, and we get the same figures. Of course, I did round up here a little bit on that. I chopped off some of the earlier zeros, so that's why that's different. So that's essentially what the variance and the standard deviation are. And this will become very important when we're looking at outliers But what we're trying to do is we're trying to get that overall difference from the average, and that's why going through and showing our work, it can be very nice just to do something like this to kind of see where the logic of this, or this part, I'm sorry, is coming from. But yes, T-SQL is a beautiful language in that it has some very nice functions that you can use. Same thing with Excel, I believe. You can use these equations and you don't have to go through it step by step. But I do think it helps people to see the step by step.